Hello everyone, welcome back to my YouTube channel. I am Avinash Koda. Today I am going to explain some of the most important topic in TOC, that is Introduction to Finite Automata. In this video, we have to learn what are the types of what is automata, what are the types of automata, the applications. Let's start with the introduction. Finite automata, the foundation model in computer science used to represent and analyze computation. They are particularly useful in understanding the principles of automata, theory, and formal language. This presentation will explore the key concepts and types and application of finite automata. What is automation? Automation is a mathematical abstraction used to describe the system, the transition between the states. It consists of a set of states, input symbols, and rules of state transitions. And also, automata can be deterministic and non-deterministic based on the transition behavior. And next, definition of finite automata. A finite automata consists of finite number of states transiting between the states, and the process input strings to determine if they accepted or rejected based on the rules. The two types, DFA and NFA. The types of finite that is are said that the DFA and NFA. The DFA determines finite automata have exactly one transition for each symbol from every state. The non-transition non-deterministic finite automata that can be multiple transition for a single input symbol. The both types have accepted the same class of regular language, but the operational mechanism is different. The component of finite automata. Deterministic of finite automata. The DFA has a unique transition for every state that an input symbol pair, and it processes input strings in a single pass, making it efficient for pattern matching. The simplicity of DFAs makes them easier to implement in the hardware and software applications. Non-deterministic finite automata. An NFA can have 0, 1 or multiple transition for a given state and input symbol. It allows for epsilon transition where the automation can change states without consuming any input. NFA are generally more flexible but can be less efficient than DFS in certain situations. Now coming to transition diagrams. Transition is usually represent finite automata and the transition. Each state is depicted as a circle and transition are shown as arrows between them, like patients, feeds, setup, ready, beyond. See the diagram, the select patients. This diagram can help in understanding the operation of finite automata intuitively. Accepting states are final determine whether an input string is accepted by automation. If the automation ends in a accepting state after processing in input, the string is accepted. The presence of multiple accepting states can increase the flexibility of automata. Language recognition. The finite automata used to recognize regular language, which are subset of language, formal language. They determine if a given string belongs to a specific language defined by automata. The key property of regular language is that they can express using irregular expressions. Conversion between DFA and NFA. Any NFA can be converted to the equivalent DFA using a subset construction method. The conversion process may be lead to DFA with exponentially more states than original NFA. Understanding this convention is crucial for implementing automata in computational models. And the coming to the application of finite automata. Finite automata are widely used in text processing, such as searching for pattern within the strings. They are fundamental in design of compilers for lexical analysis to recognize the source code. The other application include network protocol analysis and digital circuit design. What are the limitation of finite automata? Finite automata can only recognize the regular language, which limits their expressive power. They cannot handle context-free language or more complex language types. And thus, understanding these limitations is essential for selecting appropriate computation model. Finally, coming to the conclusion. Finite automata provide a simple yet powerful framework for modeling computation. They are essential in various fields, including computer science, linguistics, and engineering. The solid understanding of finite automata lays the groundwork for more advanced concepts in automatic theory. Thank you. I hope you will understand the concept of automata, types, applications, the method, what is NFA, what is DFA, how the conversion of NF and DFA. Thank you.